Are our theoretical models wrong? Or is it the universe that is the answer? The James Webb Telescope has now recorded a whole series of mysterious discoveries that contradict conventional cosmology. But what revolutionary knowledge can we gain from these impossible structures? Are our hypotheses about the age and origin of the universe still valid? Or must we now admit that we have been off track in astronomy for decades? The exploration of the universe is subject to constant changes, and these changes have led to many interesting developments in the old-fashioned way of thinking. Think of the worldview of our distant ancestors, who were firmly convinced that the Earth was the focus of the universe, around which all other celestial bodies revolved. Well, it is conceivable to be wrong today. Of course, we now know that our earthly home is just a microscopic piece of a huge mosaic in an overall scene that we have not yet deciphered. Yet, it seems that every new discovery must first overcome some internal obstacles. One example. Although Edwin Hubble recognized that practically all cosmic systems observed were moving away from us, Albert Einstein clung so tightly to the idea of a rigid and unchanging universe that he added the cosmological constant to his field equations. In hindsight, we can see that Einstein later corrected this error, calling it the greatest blunder of his career. The movements of the cosmic systems identified by Hubble were actually linked to the universe's inflexible expansion. According to our current understanding, this expansion process did not start yesterday, but around 13.8 billion years ago with the Big Bang. However, contrary to initial hypotheses, this process does not describe a huge explosion in an existing space, but rather the rapid expansion of space itself from an original singularity. Matter and time also emerged from this tiny and hot starting point. But how do we know this today? Well, simply by looking at the corresponding evolution backward. It is conceivable to trace back to the point where the density of matter and energy becomes infinite, and where all spatial distances become zero. Another exceptional proof of the correctness of the Big Bang theory is the detection of cosmic microwave background radiation. This relic from shortly after the creation of the universe is almost isotropic and fills the universe to this day. So far, the world agrees. But how do we deal with discoveries that simply cannot be reconciled with the Big Bang theory and the conclusions that follow from it? The cosmological consensus is that the first stars formed 200 to 300 million years after the Big Bang, and that the first galaxies were just small astronomical entities. This is not surprising, after all. There simply wasn't enough normal matter at that time to form true galactic giants. But the universe does not seem particularly interested in our theoretical models. The James Webb Telescope detected something last year that, strictly speaking, should not even exist: impossible galaxies. Astrophysicist Yvonne Lab and his team at Swinburne College of Technology in Melbourne analyzed some images from the near-infrared camera of the James Webb Telescope, part of the early release science program. The images showed a part of the sky near the Big Dipper, commonly known as part of the early universe. It didn't take long for Lab to understand that he and his colleagues had just detected something extraordinary. He described the initial reaction to this revolutionary discovery as follows: I ran the analysis software, and it spat out figures. Distance 13.1 billion light-years. Mass 100 billion stars. I almost spit out my drink. I knew we had just discovered the impossible: incredibly early and incredibly massive galaxies. This explains why the expert was so baffled. To explain the existence of these galaxies, one would either have to assume that the density of matter in the young universe was 5 times higher than our models suggest, or that galaxies formed in a way totally unknown to us. In both cases, scientists are faced with a major dilemma. Both possibilities require a profound change in our understanding of the universe. So far, scientists have not been able to provide a clear explanation for this unexpected discovery. The only thing that is certain is that 500 to 700 million years after the Big Bang, there were already galaxies containing 10 billion and even 100 billion solar masses of stars in one case, which were therefore similar to our current galaxy. Given these elements, it is not surprising that these objects are referred to as universe breakers. This discovery challenges what was once considered scientifically certain. The mass of stars in this early stage of the universe is up to 100 times higher than what earlier models suggested. Until now, cosmology assumed that galaxies began as small clouds of stars and dust, gradually growing over time. But is it conceivable that this is not the only way stellar associations form? This discovery adds to the perplexity of experts. Well, this mystery must be unraveled in the future, and the next discovery from the James Webb Telescope shows just how crucial this will be. The $10 billion device recently found a new record holder and, in the process, added a new enigma to the scene of stars. Identified by researchers from the University of California, the galaxy GS Z14-0 is the oldest known galaxy. The analysis of the data collected showed that this group of stars and its associated energy was formed 290 million years after the birth of the universe. But that's not all. It likely took about 100 million years for it to reach its observed size. And speaking of size, in this case, the researchers were not confronted with the tiny galaxy that our current models predict, but with a structure that already contains several hundred million solar masses of stars. Once again, the question arises, how could such a massive and brilliant galaxy have developed in less than 300 million years? And why did another deep study reveal that the object contains oxygen, as well as emission lines from hydrogen? This suggests that several generations of very massive stars had already completed their life cycles before this galaxy's formation. Once again, questions, but are there any answers? Given the discoveries presented so far, one might think that each new finding from Webb only plunges astronomers deeper into their scientific crisis. But that's not the case. Fortunately, there are answers. And what we know about how light appeared in the early universe around 380,000 years after the Big Bang, during what's called the Dark Ages, may offer some insight. There were no galaxies, no stars, and thus no sources of light. Instead, the space was filled with a dense fog of hydrogen gas. About 100 million years later, what's called reionization began, during which hydrogen ionized and became transparent again, a process literally conceivable within the first very energetic stars that stripped electrons from hydrogen atoms. But this is where things get complicated. The question of the origin of the photons that made the universe shine was fiercely debated for decades. Some theories were based on the influence of black holes, but today, Webb has lifted the cosmic veil and revealed a glimpse behind the scenes of light in detail. An international research team discovered that small universes likely produced enormous amounts of high-energy radiation. The researchers followed this astronomical lead through the Uncover program, conducted with the help of Webb's NIR-SPEC and NIR-CAM instruments. However, making the light from very distant universes visible sometimes requires a rather clever trick. This trick is called gravitational lensing, which refers to the deflection of light by large masses. Essentially, the light from a distant source is influenced by an object that appears to be in front of it, the gravitational lens. The principle is that the closer the light rays are to the mass, the more they are bent toward it. In the case of the discovery mentioned earlier, this means that faint universes were made visible through the lens of a galaxy cluster, Abell 2744, that would normally escape our earthly view. On the balance of things, these structures are about 100 times less luminous than the Milky Way. Yet spectroscopic analysis showed that they emit 4 times more radiation than previously thought. Thus, astronomers announced with relief that they had finally found the source of the mysterious photons that once made the universe shine. But before we get too excited, of course, these small galaxies did not ionize the universe 500 to 900 million years after the Big Bang and make it transparent again. They are simply representative intermediaries. Low-mass cosmic centers formed quite frequently in the early universe, collectively altering the state of the entire universe. And as usual, randomness appears often in the universe, transforming the state of things. Want to join our community? Click to subscribe now and never miss one of our exciting videos.